So now the central limit theorem for some sample sums states then when the paired population is normally distributed, the distribution of sample sums denoted by S will be approximately normal with the mean equal of that normal distribution equal to n times the mean of the population, where n is the sample size, and the standard deviation of that distribution could be calculated by multiplying the standard deviation of the population by the square root of the sample size. Okay, regardless of the sample size n, okay, when the parent population is normally distributed. Now, when the shape of the parent distribution is not normal or unknown, then we will need large samples of size 30 or more, just like with the distribution of sample means. That is very similar. Okay, let's take a look at an application. It says, according to TSA study, the weights of passengers carry-ons are distributed with a mean of 25 pounds and the standard deviation of 4.5 pounds. So the mean of this distribution is 25, and the standard deviation of this distribution is 4.5. Find the probability that the total weight, or the sum of all weights of 200 randomly selected carry-ons, is less than 5,200 pounds. Okay, so the n is 200, and we're looking for the probability that the sum of those x values sums is less than 5,200. All right, so the sample size is large. That means that we're gonna have a normal distribution of the sums. So the sums follow the normal distribution with the mean of n times p. So the mean of sums is 200 times 25, and that's going to be 5,000. And the standard deviation of samples is going to be the standard deviation of the population, 4.5, multiplied by the square root of n, square root of 200. So that is approximately 63.6396. Okay, so these are our parameters for the normal distribution, and we're looking for the probability that, okay, so the mean is 5,000. 5,200 is on the right hand side, and we're looking for the probability that the sum is gonna be less than that, so on the left hand side. So again, let's use technology. Once again, I have my normal distribution. I'm going to put in the mean of 5,000, and the standard deviation of 63.36396, and x of 5,200. And I'm looking for the probability that it's going to be less. or equal to that value. So that probability is 0.9992. So that was the application of the central limit theorem to the distribution of sample sums. Now, as you could see, all of these distributions follow the normal distribution, the distribution of sample means, sample proportions, and the sample sums. You have to verify that they follow the sample size is large enough, or that the sample size or the samples are drawn from the normal distribution before applying our methods for normal distribution. But other than that, they all follow the same patterns.